Now an M with a little circle with a dot in it basically stands for one solar mass. And this is kind of what we kind of refer, or this is our kind of sort of unit that we compare other things in the solar system to. So here is our normal kind of sun that we know. And basically, if we look at stars which have a basically anywhere from sort of 0.5 up to about 10 solar masses, these are sort of the fairly lightweight and smaller stars. And what I'd like to look at in this video is their evolution from a main sequence star to maybe some kind of red giant, and eventually to a white dwarf. Now, inside the star, for most of the time as it's a main sequence star, what we have are two forces acting. We have the force of gravity in that's pulling everything together, and we have this radiation and gas force due to the effect of the nuclear explosions, which is kind of pushing everything out. And everything is in equilibrium and everything's nice and happy. But what happens is that these bits of hydrogen, as they fuse together to make more helium, we start to actually decrease the number of hydrogen atoms which are left. And as the star kind of keeps burning up more hydrogen, we call it hydrogen burning, but it's not burning, it's this fusion of hydrogen together. As time goes on, we start to run out of fuel. And what happens is that when we run out of fuel, the force of gravity pulling everything in is still pretty much the same, but this radiation pressure outwards decreases. And when this happens, this is when the star starts to become a red giant. Now basically what happens is that the core of this star itself basically kind of sort of collapses. And in the core itself, it's not actually hot enough for this sort of helium to sort of fuse really into anything else. So you've basically got this kind of inert core. But surrounding this, what we then have is, as things start to collapse, some of that potential energy turns into kinetic, and things heat up in the atmosphere around it. And it's in the atmosphere around this that we still have some fusion occurring. But this is actually where this atmosphere actually sort of swells and gets bigger and bigger. So here I have effectively the large kind of atmosphere of the star. Now, because we have effectively the same amount of energy being given off over a larger area, it means that the temperature actually cools down. And what we see then is that the temperature of the star cools down and it changes from like a sort of white or yellow colour to a red colour. And so this is basically what's happening inside the red giant. This is where you've got these kind of large outer sort of layers, a big atmosphere where hydrogen is still fusing to hydrogen to make some more helium, but in the middle there's no more fusion because the helium here can't overcome the kind of electrostatic repulsion. So basically this is what happens in the later stage of the life of a star, both a small mass star and also some of the larger ones. But this is what we call a red giant. However, as you'll soon realise, we don't always have enough hydrogen to sort of actually kind of fuse forever. And eventually we're going to start to run out of fuel again. And that's when we get to the third part of the sort of the end of the life of this star, which is what we call a white dwarf. Now basically towards the end of the life, what happens is these outer layers tend to sort of drift off into space. And that leaves this kind of very dense core behind. So what we have is, again, most of the mass of the star is in this core. And effectively this is really, really hot. Now no fusion is taking place inside the white dwarf. It's called a white dwarf because it's very, very small, but effectively it's also incredibly hot. So the surface temperature might be something like sort of 30,000 Kelvin. And effectively it's just this kind of leftover heat that's stored in there. And that heat does, disappear over time as it's radiated off. But this is quite a slow process because there's no conduction, no convection, and therefore there's this radiation of heat. So basically the white dwarf is how our sun will end its life.